So, well, this video is dedicated to going to introducing you to calculus. But before I go into there, right, I need to touch up on two main concepts. One is functions, and what these are, and limits. Limits. Yeah. Okay. And then from these two, then I can actually start delving into what calculus is all about. Yeah. Okay. So first, this thing called functions. So basically, a function is a special type of relation between two numbers, kind of. How do I explain it? Okay. So if I have some number, and I'm going to call this number box, right? And it goes into my function. Okay, and I'm going to call this function f of x, my function of x, right? I get some output. So I have some input, I put it into my function, and I get some other output. Yeah? Imagine if I give an example. If my f of x is, in this case, I'm going to write it as x squared, right? And so if I give it some value of 9, right? So then I will give it an input value of 9. That means I would have to compute 9 squared, and then my output would be 81. And so if I had like 3, then I would put x squared, so that's my function, and then I just get out 9. So then I would represent this as if f of x is equal to x squared, right? That means f of 3 is equal to 9. Yeah? So this is my function, right? Or I can also write this as y equals x squared. So f of x and y is basically interchangeable. You know, they're basically the same thing, right? What I can tell here is this is my function based on x and not based on y. Like say if I have f of z is equal to z squared, right? That means f of 3 is equal to, again, 9. So, I mean, like, I can represent it in different ways, but often I would just represent it as f of x, because often we represent everything in terms of x and y. It's easy to graph that way, right? We have an x-axis, a y-axis. It's easy to plot everything, right? Okay, so I think you get the idea of what functions are, okay? So, if I tell you, okay, now, if I tell you that f of x is equal to x squared, okay, wherever I have an x, right, I just have to square it. That's what the function does. Whatever value of x I have, I just square it. If I have f of x is equal to x plus 1, okay, so that means whatever I have inside the bracket, I just add 1. You see here, right? So that's basically what this function notation means. You just need to understand what it means, right? A lot of math is just like English in a sense. If you have sentences, right, and then each word has its own meaning. And so if you know what the words mean, then you can understand the sentence. So if I say f of x is equal to x plus 1, f of x has some meaning, equals has some meaning, and x plus 1 has its own meaning, right? So what I'm saying is if so what I'm changing x, how I change x is by adding 1. That's what I do. So if I have f of 3, I just get 3 plus 1, which is 4. Yeah? So this way it's easy to compute. Okay? So that means in this, I'm taking this example, right? If I have f of x plus 2, then I just get x plus 2 plus 1. So whatever I have in the brackets, I replace it, yeah? If I have f of g plus 5, then I just have g plus 5 plus 1. Oh yeah, this is also equal to x plus 3, and this would also be equal to g plus 6. So you kind of get how this function notation works. Okay, I'm just touching up over here, yeah? Okay, I'm just going to give another last example, f of, okay, and so this, I'm going to use this example, f of x plus h. Okay, some number h, yeah? And so this gets me x plus h all squared. Not hard to understand, right? So whatever I have in the brackets, I just square it. And that's what this function notation tells me. Often when we graph things, right, we always say that y equals f of x. Because when I compare f of x is equal to x squared and y equals x squared, if they're both x, this thing is the same thing, then I know that f of x is equal to y. So often we would represent our y-axis as f of x. Yeah, I don't think this is too hard to understand. So my function of x is what y is. So if I give it a certain x value, I get a certain y value. And that's basically what our y equals something of x equals. And so you can understand what this is all about. Next up, we're just talking about limits. Okay, so what limits is as I get closer and closer to a certain value, what does equal to? If I say the limit, this is how I represent it, as x gets closer and closer to 6 of the function x squared minus 6, right? Here I would just sub x in. Okay, so this whole thing is just 6 squared minus 6, which is just 30. Okay, and I just get a nice clean example. Where limits is actually very useful is, say if I had an example of, okay, x squared, no, actually, no, not that x. Actually, yeah, x squared minus 3x plus 2. Okay, all over, how does this work? X minus 2. I think this would work. Yeah, it would. Okay, yeah, and if I take the limit as x approaches 2, right? When I sub x equals 2, right, then I just get 2 squared minus 3 groups of 2 plus 2 all over 2 minus 2. That's just, this evaluates to 4 minus 6 plus 2 all over 0, which is just the same thing as 0 over 0. Now, first off, we cannot divide by 0. Literally, it's just like, let's just call it mathematical law. We cannot divide by 0. The simple reason is if I have, if I have 3 times 2 equals 6, right? Then I can also rewrite this as 6 divided by 3 equals 2, right? Then if I say, let's see. Yeah, if I write it as 6 times 0 equals 0, right? We know that. And then then what about 6 divided by 0? We can't solve that, right? I mean, you can say, actually, instead of 6 divided by 0, I'll do 0 divided by 0, right? 3 times 2 is 6, so 6 divided by 3 is 2, right? So then 6 times 0 is 0. Okay, I would say that it would be 6. But then again, I can also say that 7 times 0 equals 0. And I can say the same thing for any number. That means 0 divided by 0 doesn't give me any exact value. Therefore, this just gives me an indeterminate value. And that's what we call this, indeterminate. Basically put, we cannot get anything. So when I have any number, I'm just going to call it any number, divided by 0, we cannot get any solution. Basically, we're not allowed to divide by 0, right? And so basically what this means is I cannot sub 2 into this equation. If I sub 2 into this equation, we're divided by 0 and I broke the rule, right? Because when we break the rule, we're not going to get any solution. Actually, I'll just rub this out. Okay, so what we do is we take the limit. As x gets very, very, very close to 2, what is this whole function going to become? X can't be equal to 2, of course. But let's say if we get to like 2.0001, or if I get 2.0000, like I have infinitely many, no, not infinitely. If I have heaps and heaps of zeros, and then I have the 1, 0, dot, 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 0, 0, 1, right? And if I sub that in, right, that's not exactly 2. But what happens if we get really, really small? Okay, what does this whole function become? And this is the idea of limits. This is where limits is useful. The way that we can evaluate this is, let's try factorizing the top. And then we get x minus 2, x minus 1. right? And this is all divided by x minus 2. Now what I can do here is I can cancel these two. That just gets me x minus 1. And now I can sub 2 in. 2 minus 1, which is just... Alright. When you're working things out, right, you have to carry on that limit until you sub it in. And when you sub it in, then where you don't need it, then you just get 1. And this is our solution, right? If I take the limit as x approaches... Wait, I'll get my function here first. X squared minus 5x. Let's see. Minus 6, I think. This should work. All over... wait, is it minus 5x? Yeah, it's plus, whoops, plus 6, all over x plus 3. X plus 3? X minus 3, sorry. So as x approaches 3, when I sub this in, right? Now I can't sub x as 3 in, right? So I would have to write it as the limit, and then I would have to factorize this. So then this just gets me x. What does this get me? X minus 2, x minus 3. Yeah, that works. And then all over x minus 3. And now we can cancel that out. So the limit, alright, I have to write the limit as x approaches 3. So as x gets closer and closer to 3, what does this become? That's what? As x approaches 3 of, now these two cancel out, right? So then we just get x minus 2. And now I can sub 3 in, which is equal to 3 minus 2. That's just 1. Yeah? So you understand how this kind of limits thing work. Because we can't substitute it straight in, but we can get closer and closer and closer. Okay, now we get into the real juicy part. The real interesting thing, okay? So I'm going to, so consider this example. I got me a parabola, yeah? This nice little parabola. I'm going to plot the point 1, 1, okay? And this is like a fixed point. I'm not going to change point A at all, right? And I'm going to give it some arbitrary position. I really don't care what this value is, right? So now based on the function thing that I was telling you before, right? So then I can represent this value. Okay, I'm going to represent this original value, this A, right? I'm going to represent A, okay? Instead of giving it the specific value 1, 1, I'm going to represent A as x, comma, f of x. So it has some x value and some y value. And my y value is f of x. That's what we said earlier, right? Y is the same thing as f of x. Some function of x, right? And we know that f of x is equal to x squared. That's our basic parabola. F of x equals x squared. Yeah? And I'm going to label point B. Okay, remember, I'm going to give it like some arbitrary value, right? And I really don't care what this value is. Okay, what I'm going to say is that B is some x value ahead of A, is some value bigger than A, right? It is, I'm going to say instead of, okay, so the distance, the horizontal distance between A and B, I'm just going to call that h. So that means this would be x plus h. As you can see, this is x, and so my distance, my horizontal distance between them, in this case is 0.57. I can shift it around however much I want. I really don't care, right? So that this horizontal distance, the difference in x values between B and A is h. So this would be x plus h. And so my y value would be f of x plus h. Yeah? So remember, h is just the distance between A and B, like the horizontal distance, only the x values, right? If I were to represent this, then I would get, wait, I'll just represent it quickly. Have a line to the x-axis, to A, okay. Quickly, just give me a sec. Okay. Okay, so you see the distance between A and C? So you see that C has the same x value as B, right? So the horizontal distance between A and B, right, is this h value that I'm telling you about, right? So I can shift this around, and I'm going to call this a fixed point. Yeah. Okay. So we know what's going on here. Yeah, I think. Okay. So we see that the horizontal distance, or the distance between A and B, is just h, and so that's why I represent this as x plus h. And this is my y value because whatever value of x I have, I plug it in, and so I have f of x plus h. I can again write this as x plus h all squared, but I'm making this as general as I can. Okay, and you see why I'm doing this really generalized, because you can apply this to different curves and not just parabolas, not just straight lines, not just cubics, into any function whatsoever. I can make it sine of x, I can make it cubes, I can make it, I don't know, 2 to the power of x instead of x squared. So it's like many different things I can apply this to, and you see what I'm doing. Okay. So what I want to know, right? I'm just looking at this parabola, and I'm thinking, right? You know how our line has a slope? You see how I have a line that has a certain slope, right? At the point A, when I'm looking specifically at this point A, what is the slope of the parabola? What I mean is if I get closer and closer, right? Whoops. Okay. As I get closer and closer, what is the slope of this point? You see how it starts approximating into a straight line? You see how it looks like it's basically a straight line at this point. So what's the slope of this line? That's what I'm curious to know. Yeah? And this is what one of the two major parts of calculus that we cover is simply finding the slope of a curve at a given point. So I have a certain point, and I want to know what the slope is at that point. And so how we do this is we use this function notation, and I'll show you how it works basically. So now if I have this line between A and B, okay, so now my slope of this line is, okay, what's the slope of A of this specific line? The slope of the line is the rise over run, right? So the rise is my change in y, right? My difference in y. So that means my rise, okay, so my slope equals rise over run. Yeah, we know that in lines, right? In any linear graph, then we have our slope equals rise over run. So my rise is my difference in y. So I can write, and this is, you'll probably also see this in physics and stuff. So my difference in y over my difference in x. Okay, so my difference in y is the difference in my y values here. So then I have f of x plus h minus f of x all over x plus h minus x. And so I'm just going to simplify this through. Then I have f of x plus h minus f of x all over, now x minus x just gets me 0, so I just get me a h. Okay, so I got this little neat little thing here. Okay, now what I'm trying to do is I'm trying to make h as small as I can. That means my graph here, it starts becoming more and more accurate. You see here, right, that this slope starts getting more and more accurate. So now I'm taking the limit as h gets closer and closer and closer to 0. I can still zoom in, and I can still get closer and closer. And so this is the limit as h approaches 0. So the limit, so I'm taking, so the slope at that point, so slope at point A equals the limit as x approaches 0, not x, sorry, h approaches 0. H approaches 0 of f of x minus h, x plus h minus f of x all over h. Now if I sub h equals 0, then I'm just dividing by 0. Remember, that's not allowed, right? And so this is how we alter things so that we can evaluate it, okay? So then I'm going to, what I can do, right? Now I know that f of x is x squared. So that means I know f of x plus h is just x plus h all squared, right? Whatever I have inside, that's what this function tells me. If whatever I have inside, I just square it. Same thing goes here. So whatever I have inside the bracket, I'm just squaring it. So then I have my limit as h approaches 0. Now then I square this, right? So the x plus h all squared minus, now f of x is just x squared all over h. Now this thing is just lim h approaches 0. Now this is just x squared. Now I'm just expanding this binomial thing, right? So that's plus 2xh. And then what else do I have? I have r plus h squared, right? I expanded this nicely. And then I have an x squared lying around all over h. Okay, my x squared here and this x squared here cancels out. So then I have me a lim h approaches 0. And then so the x squares cancel out. 2xh plus h squared all over h. Now since they're all h's here, right? Now I can start dividing everything by h. So that my limit as h approaches 0. Now I get 2x plus h, right? So 2xh divided by h just gets me 2x. H squared divided by h, I just get h. Yeah? And now I can substitute it in. So this just gets me 2x. Okay? And so now I'm telling you, so this is, so basically at point A with a certain x value, right? I can tell you that the slope here is 2 times that x value for this specific parabola. And what I can show you is, okay, so as I was saying, right, as I get closer, so I can write it as y equals mx plus b, right? And so my m is my slope of this line. So as I get closer and closer, it's already become 2x minus 1, and the slope here became 2, right? And this is what calculus is basically all about. Finding the slope of a certain point in a curve. So then, from here, right, I've proven to you that the slope at point A is 2, because when I sub the x value of 2, I get me, if I sub the x value of 1, I get me a slope of 2. Okay, so forget B and C, and forget these lines. These lines don't matter. Okay, that line doesn't matter either. Okay, so looking back at our original parabola, yeah, what this also tells me is that this is the slope of the tangent as well. The slope of the tangent. So the tangent is a point, and you see here that the slope of this. Wait, I'll just delete these. Bye. Delete. Okay, so you see that the slope of this tangent here also follows the same rule, because this is the slope of this tangent is basically the slope of this given point. And so when I shift this point around, then I get different slopes. And you notice how the slope of this is always equal to 2 times the x value over here. If I put x is equal to 0.5, I basically get 1. I'm just a little bit inaccurate here. Yeah, see, 1, right? And so I can plug it into this special function, right? So if I have f of x plus h minus f of x all over h, and the limit as h approaches 0. Remember, we're just narrowing down our range thing. We're narrowing down the difference so that we can solve for this slope. Yeah? And I think we're done for now. I hope you understand how this calculus thingy looks like, and this how it works. By the way, this field of calculus is what we call differentiation. There's other fields of calculus, and they involve different other uses, and they involve other things. But this field of calculus, the one that you usually start off with, is based on this. Finding the slope of a function, just some correlation between x and y. So this, in this case, is just x squared, right? And I want to find the slope of this at a given point. So at some point, I have some x value, and I want to know what the slope is at that point. So here when m is 0, then the slope here is 0, because 2 times 0 is 0, right? And yeah, I think we should be done.